Hello, my name is John Holden, and I am a senior undergraduate researcher in WVU's Division of Forestry and Natural Resources, working in Dr. Steve Chen's Quantitative Forest Management Laboratory. This afternoon, I will be sharing my research conducted this summer through WVU's SURE program. This study, establishing optimal forest density for growth of California black oak within the Sierra Nevada, was conducted by myself, Kathleen Conroy, Dr. Steve Chen, and Dr. John Wei Zhang. So let's begin with some background. The tree species in which this study is focused is California black oak, a species found throughout California and into southern Oregon. For the rest of this presentation, I will refer to California black oak simply as black oak, but it is important to note that California black oak is not the same species as the black oak found in the eastern United States. Black oak is shade intolerant and thus depends on an open gap structure to survive to maturity. Black oak is also highly wildfire adapted through its ability to sprout new stems from dormant buds found at the base of their trunk. This is done in the event of wildfire-derived mortality. Black oak utilizes this ability to establish itself within a gap before its faster-growing conifer counterparts. We can think of this as California black oak giving itself a head start at site establishment. Prior to the adoption of fire suppression within these forests, low-severity frequent fires would remove black oak competitors before they can develop thick enough bark to resist the effects of wildfire. With the retention of faster-growing, shade-tolerant conifer species such as white fir and Douglas fir, former black oak forests are being converted to mixed conifer covers as conifer species continue to shade out black oak. However, there is a potential remedy for this issue in the form of a silvicultural technique known as crown thinning. Crown thinning is the process in which codominant and dominant canopy position trees are removed to favor the growth of trees within the same canopy class. This can be done to mimic a structure similar to that created by wildfires and thus allow for oak forest retention. This leads to our study's objective, which was to determine what forest density best supports the growth of California black oak. Now, I will get into our study's methods. In 2016, United States Forest Service researchers collected inventory on a black oak forest site found within Lassen National Forest in the Californian Sierra Nevada. This site has experienced 2 wildfires in the last 2 decades, not counting the current Dixie Fire burning through the area now. Data from this time was used to categorize plots by their oak density and composition. Density was defined as overall cross-sectional or basal area, while composition was the ratio between oak basal area and conifer basal area. This summer, we utilized this data to select plots from a gradient of different density composition categories in an effort to analyze their current conditions. Now, I will talk about our results. Figure 1 shows the change in oak and overall basal area by plot, delineated by their 2016 oak density composition category. Percent change in oak basal area was used to demonstrate change in oak density over the last 5 years. T-tests were performed on percent oak basal area values within each category's 2016 and 2021 values. However, significance was only determined for percent oak basal area change in the high oak density, high oak composition plots. Figure 2 demonstrates the change in density by species within each oak density composition category from 2016 to 2021. We observed that the low oak density composition category experienced an increase in oak basal area while others experienced decrease. Figure 3 demonstrates that the largest increase in average oak diameter was found in the low category as well. So, what does all of this mean? Figure 4 demonstrates that sites of initially low oak density and composition may fare similarly to that of initially high oak density and composition sites. We currently believe this to be due to low levels of inter- and intraspecific competition in low sites, in combination with greater levels of intraspecific competition among oak in high density and high composition category. Medium oak density and low composition fared the worst over the 5 years, which we believe to be due to high levels of competition from fir counterparts. Thank you all very much for listening to my presentation. I will be looking forward to answering any questions.